How are you guys doing? Good? Fantastic. How was lunch? Okay. Short, maybe short. Okay, guys, so yeah, just a couple of words. If this is the second session, welcome back. And if this is the first session, definitely welcome. I will need to introduce myself as for the Savoir Vivre. Today I'm delivering 3 sessions. This is the second one. As you already know, as you can see on the slide, my name is Paula Paula Januszkiewicz. This is a very Polish last name because I'm from Poland, probably that's why. And a couple of words, I'm also CEO of Secure. This is a company that I have established 11 years ago, and together with my team, which is 42 right now, we do cybersecurity research. So that's a little bit of a background. Now, a couple of words, of course, about the presentation. So today we're going to be talking about malware, and we're going to be jumping into different situations where malware is involved, and we're going to be performing the analysis. Yes? So our job is going to be to see different types of tactics, mechanisms that malware uses. We've got 45 minutes for that, so we will try to pack it with lots of knowledge, so be ready for a little bit of a ride. I decided, by the way, to increase the session levels because I've got 3 sessions, so I kind of can do it. So this is like the second degree of session, and the last one's going to be a little bit more hardcore as well. So if you're ready for that like technical ride today, that's a good moment, I guess. So that particular session basically covers different types of malware samples. And my goal for the session itself is to show you these techniques so that when you're going to leave this room, you will see, okay, so malware works like this, malware does that. In order to prevent, I need to choose this and that. Yeah, so this is in general the generic direction in which we're able to implement something that could prevent malware from pretty much working in our infrastructures. Yeah? And the reason why I'm saying generic, it doesn't mean it's going to be easy. Generic means like Windows, it's an operating system that is amazing, but it's over somewhere, yeah? So when we know exactly what are the execution mechanisms out there, it feels good. That's my point. Yeah, so it's good to have that good feeling when we're going to leave this room. It's like, okay, that's how code executes. Let's do something about that, yeah? And that did not change for so many years. And this is something that I would like to start with, because in general, when we are thinking about malware, and we are calling it even a modern malware, it's a little bit of a twisted title over here, because we think like, okay, is there something like hiding out there to hurt us, yeah? And sometimes we can see, even by our customers, that there is this misconception about that malware is so amazing right now that we cannot really prevent it. No, that did not really change. It's just that there's a bigger engagement of money in hitting companies. That's why we are able to hear about that more. And that's why basically I'm making a little bit of an intro that the landscape has changed, but the platform did not. Yeah, so the malware that we are dealing with, I don't want to say it's the same, but the way how it executes is kind of the same. Yeah, so, but it's just more often. Now, just to give you a little bit of more example here, for the whole vacation, my team actually expanded. It's a true story. It was quite a crazy project we had, because our customer, having over 1,000 servers, they get hit by the ransomware, which, by the way, could execute. Yeah, so there was an executable that could run, a known piece of code that was there, and they allowed it to run, besides the fact that it's a company that had 42 domain admins, but that's a different story, so you can imagine like the whole situation. And their servers, their infrastructure in general completely gets smashed. So we get a call that we have to be on site pretty much immediately. My team expanded from 42 to over 60 people in a week, like this. I don't know how that's possible, but it happened. And then we had to help them to fix their infrastructure and in general to evaluate the problem and the scope of what happened. And very exciting, yeah? So it's sad to say that, but when we get on site, it appeared that yes, it's another executable that nobody knows, and it just ran because someone did a mistake, and here we go, yeah? So not that exciting, yes? All these cases that we hear, they sound good, but at the end, when we think about what actually executes, it's the same things. So it's good to know what these things are in order to learn how to prevent them. Are we able to bypass different types of solutions like code execution prevention and so on? Yes, but depends really how things are configured. That's why when one of our customers said, hey, we've got an code execution prevention implemented, and my question is always, is it well done? Yeah, this is a very strange question to ask, because what does it mean to have it well done? Yes, it means that we have to spend gazillions of hours to figure out how that code actually executes so that we can fix it. So this is a bit of an ironic question that I'm asking out there. Anyway, whenever we've got these different types of solutions that are supposed to prevent malware, the first question I think we should start with is, can they be stopped? So this is something that I would like to start with. Yeah? So let's go immediately to technical demonstrations where we're going to be learning, are we able to actually stop different types of solutions? And I'm treating this as a warm-up demo because it is a bit of a warm-up demo. It's straightforward, quite easy, but very useful and very important to know. So here we go. What we're going to be doing, we're going to be stopping an antivirus. So on the market, we've got two types of antivirus solutions. We're going to learn that in a second. These ones that can be stopped, and these ones that can be stopped later. Yeah. Long story short, that's quite ironic, I know, but these ones that can be stopped means that eventually we've got a service that allows to be stopped. Is it good or bad? You can judge by yourself, but let's have a look. Yeah. So we've got over here a service. I call it MacAfio. I mean, no coincidence, obviously. Okay, so here we go. So we've got our service MacAfio, and just for the reference, of course, let's just have a look. Even though we do CMD, you can see that let's just make it the worst, say a domain admin. Yes, it doesn't matter really, because I'm always measured by the local group membership, but again, here we go, I'm a domain admin. Domain admin tries to stop an antivirus, yeah? So let's figure it out. So we've got a MacAfio, and we cannot do it because it's grayed out. Yeah? So what can we do? Well, we can try maybe doing it within the command line. Yeah? So I'm going to copy the name of the service, and let's just do net stop over here, and then MacAfio, and then it says access is denied. Yeah? Now, here's a little bit of a story for you, if you don't mind, a little bit of a personal story of myself. My grandfather, he's a very cool guy, you know, and this is regarding this, of course. So he is one of these grandpas that has his own garage, where he's got a car. This car has been into pieces like 10 times, you know, so this is his hobby. He puts it into pieces, he puts it back, into pieces back, and so on. In his garage, everything is perfectly aligned, all the screwdrivers from like smallest to the biggest and so on. So he's a geek, for sure. And when I was younger, he took me to kind of like a street market, where you're able to buy everything for like $1, yeah? So we call it in Poland like an Eastern European market, because you can buy pretty much everything over there, and not everything is legal and that kind of stuff. So let's just leave it without a comment, yeah? So he likes to go there, and then basically he bought like a kitchen clock, like a little clock. And he went back home with me, he took a screwdriver, he'd open it up, he put it into pieces, and I'm observing this, he put it back, tick, tick, once again, turn it on, works, yeah? And I'm observing this, and I'm asking, okay, why did you do that? And he says, because I paid for it. And I'm like, ah, okay. Does it mean that whatever I paid for, I need to know how it works? And he's like, pretty much like this. And everything that you paid for, it's yours. And I'm like, okay, this is a very smart thing to say. So whenever I see access is denied, I'm thinking about that. I'm like, come on, I paid for it. Yeah. There is no access is denied to stuff that I own over here. So let's figure it out how to make it work, yeah? There's another saying for this. I call it sometimes a dream of a developer. But access is denied, which means developer wants us to think that access is denied, but that's obviously not true. So let's have a look. So what we're going to do, first of all, let me show you something. We're going to do SC query, MacAfio, and then we can see stoppable, pausable, accepts, shutdown. Yes, this is a very important information, which means we can. Okay, good news. So what we're going to do later, we're going to go to the CQ tools. Let's just do that. And then let's use Mark Rusinovich, psexec, sid, cmd.exe to elevate ourselves to local system, to see if we are able indeed to actually stop it. Yes? So we've got who am I local system, and then I do net stop, and then let's paste it, and then we've got access is denied too, and that's really weird, because this is a system, right? System like can do all of this stuff, yeah? It's system with a big S, as we learned on the previous session. So what we're gonna do in a moment, we're gonna analyze why there isn't actually access is denied. So we're gonna do sd show, in this particular case, it's a McAfee. Let's do that. sd show, SD in this command stands for security descriptor. And here's a lesson, because everything in Windows, it's really a matter of privilege or permission, yeah? So this is how we are describing security in the operating system. Privilege is what we can do, permission is where we can get access to. And we all know that, but it's an important perspective to get, because even services, of course, they must be described in order to learn who can actually start them and stop them. And there's always someone who can do it, that's A. And B, there's always someone who can change it. And security descriptor can be changed by local system. That's the point. Whatever they say over there, yeah, we can change it as a local system. So this is what we are looking at. This is called SDDL, Security Definition Descriptive Language, a language of love, for sure. It's a very painful relationship. But we can look at this, and then we can see that we've got this D first. That stands for Discretionary Access Control List. And S stands for System Access Control List. And it means that D is like ACLs, pretty much. We've got like chunks. And this first D stands for deny. And then we've got WP, SD, WWO. That goes in pairs. Yeah, so we've got a WP, write property, SD standard delete, WD, write DAC, discretionary access control list, and WO stands for write owner. And then we are saying that authenticated users cannot do that. Who cares? Seriously, they cannot. This is a denial, so we could even skip this, by the way. It's just a little bit of a comment. Then we've got built-in admins, and then we get system. Hey, so we want to make system to be able to stop the antivirus, but why don't we just spread around, and why don't we just make everybody to stop the antivirus? Yeah, let's do it. So I copied that string over here. So we're going to be analyzing it over here, so let's do the word wrap. And the only thing in order to be able to stop the antivirus is I do this. Yeah, so I change D to A, format, word wrap, Control A, Control C, and then we do SCSD set, because we can, McAfee, and then basically we do stop it by doing net stop. We can do it from system or admin, doesn't matter. We can do it from admin. Let's just do it from admin. Net stop, PJ, I tend to do it always, McAfee. Here you go. Yeah, and then it was stopped successfully, yeah? Here we go. Now, interesting comment, by the way. Yeah, as I mentioned, like the name over here, it's accidental. So, so here, why did it work? Because here we are saying that deny system, right? And deny system, it's like deny kind of like, sometimes we hear that it takes precedence. And that is another interesting thing over here, that in Windows, deny does not win. It doesn't. Who wins is who is first on the list. This is a very important thing. And this is a kind of like a Santa Claus doesn't exist information, I guess. But in general, that's why, because I changed authenticated users to A, yeah, that overrides anything that goes to the right. And that's how it works in the permissions in Windows. In SDDL, it's a good representation of that. Yeah? So this is how we stop antivirus. Yeah? Now, we stopped it because it could have been stopped. Now, when we look at, for example, and again, I mean, we are on a Microsoft conference, so we could kind of do that. We could be playing with the Windows Defender ATP and so on. I'm going to give it actually as a good example over here. Yeah? So let me show you what do we mean by this. So if we want to stop it, and I'm going to start the console on my local laptop with the administrative privileges, here, yeah, if we do net stop, once again, net stop sense, then it says the requested pause, continue, or stop is not valid for that service. It's a different type of a message. Yeah? Because if we do SC query sense, then we're able to see it's not stoppable, not pausable, ignore shutdown. A bit of a dream too, because you can still figure out how to stop it, but that's not the way. And that way, in my opinion, to be able to stop the antivirus, it's a little bit easy. That's why it's important to choose an antivirus that actually has different types of features, not only the detection, but also anything around that secures the file, the process itself, that prevents from interacting with it. Yeah, and I don't work for Microsoft, yes, so you guys probably know that, but that's my independent opinion about that, yes, so just, you know. Okay, so we've got this. Now, what we're going to be doing next, we're going to be learning about different types of techniques, how things can be discovered, and then we're going to get into the details. So there are two major techniques that we recognize in the old school antivirus that we've been using for years. Yeah? One is signature-based, and we know what it means. We just know the file, that's it. But another one is behavior-based. So we kind of like are able to see what this file does. There's a set of predefined behaviors that we are able to judge. And when the certain type of a file does something, we react. Yeah? So this is very easy. But it's so easy, too, to define a behavior that is from the outside of that list. And that's why, for example, when we are able to hear that someone is bypassing antivirus, which sounds very geeky, it means that we are designing a behavior that will actually not be recognized. Yeah? So the more we are advanced in detection, the more difficult it is. Yeah? What are these different types of techniques that are allowing us to actually avoid antivirus? One of these things is, of course, wrapping. Yeah? So a little bit of a theory, and let's get into practice immediately. Yeah? So we're able to play, this is a little bit like a 90s old school technique, but it still works. It's not so old. And we're able to wrap certain piece of a code in a code in a code using different types of techniques of execution. Yeah? One of the wrapper or kind of like repacker, so to say, that we are using, I'm saying we means our team, is that we are wrapping the code a couple of times. We've figured our own method to load it directly from the memory, and we are putting it into chunks. If you're on a developer side, this is called in general a reflection technique. So we have designed our own way to actually run it directly from the memory. And this is something that antivirus does not discover. So in general, antivirus, what I'm saying, in the form how it is, it's a little bit of an old school solution. Yeah, and we all know that. That's why we are getting into the direction to the machine learning and intelligent threat detection. Now, another different types of techniques that we've got, obfuscation, of course. So in general, it's a way to change the code so that at the compilation it looks a little bit different, changing different types of function names and so on, different types of variables. In general, lots of spaghetti code. Yes? So that's why we are able to avoid antivirus, maybe. But again, it depends on the detection techniques that are within the antivirus. And of course, anti-debugging, so different types of things in a code that are preventing from us, or preventing in general us, from analyzing of what this code does. For example, there is a direct statement in a code that if you run it in a virtual machine, this code will never run. And this is something basically that I would like to quickly show you in one of the virtual machines that I have a sample of something that we call a coin vault. Coin vault was a very interesting ransomware, one of the super interesting ransomware, because this is this ransomware where the servers containing keys, they were found, and people eventually were able to actually decrypt data, which is quite an interesting history too. So if you would like to ever check that, that will be nice. But look, so I am running over here ILSpy. ILSpy, it's in general a decompiler for the .NET code, so for the managed code. Would I recommend that tool? Yes, it's free, that's why, yeah? But you can also use IDA, you can use also .NET Reflector, there are different tools for that, yeah? So I've chosen this one because it's nice and simple, especially for the presentation. So over here, I've got one of the parts of the coin vault, and over here, when we look at the evasion technique within the malware, you were able to see that there's like the Wireshark Network Analyzer, WPE Pro, and so on. So in general, we're able to see that in this code, when, for example, we've got a manufacturer for the virtual machines, what that will be, Microsoft Corporation, VMware, VirtualBox, and so on. So when we got that, malware will never run, for example, which is quite funny because it means it's not a very practical ransomware, isn't it? Because everybody is like kind of running virtual machines right now. So where that will actually run, yeah? But anyway, this is just an example that we got over here. Okay, so this is basically how we are getting into the subject. Now, whenever we are thinking, of course, about bypassing antivirus, so whenever the antivirus is out there and we are wondering how we're able to execute the code that will actually go, I've mentioned this reflection technique that allows us to run things directly from the memory. So the compile code that is, or compile code actually, that is out there within the memory. So I would like to show you how it works, yeah? So let's have a look. First of all, let me get into the tools, and then I would like to show you one of our concepts here. So, here we go. So I've got over here something that we call CQ repacker. Yeah? This is basically, as you see, version 7.4, 7.2, and so on, because every single time we figure out something, antivirus companies, they also figure it out, and then it's like a cat and mouse game all the time. So to make something nowadays that is not detected by antivirus, it's not very difficult, but you need to keep going, yeah? Okay, so we've got a repacker, and I have over here a Mimikatz. This is a Mimikatz that I have downloaded today. So this is a fresh one, so recognized by antivirus and so on. And in order to download it, of course, you have to enable it and so on. So repacker itself will actually allow to repack the Mimikatz. And I would like to show you how that solution works. So we've got a 0, 1, 3, and so on. And this is basically, first, in order to run it, let's see if it works, because we could completely destroy it, and then it's amazing, but it doesn't work. Let's see, because it actually works, yeah? So first, let's run it. So we've got this one. And then we will need to specify here a bunch of parameters. So one of these is going to be pass. So we are putting a password additionally on the top of that, which is actually a file name. And we're going to do minus or slash time, or just we can do time. And then I'm going to put 0, which means it won't sleep. This is also one of the evasion techniques to have. And as you see, I'm in a Mimikatz, so Mimikatz works, no problem. Yeah. So we can now steal credentials, do pass the hash, and all the different types of things, which is great. Now, one thing is to run the tool, but another one is, of course, what does this tool do? And that's this behavioral thing. Now, Mimikatz itself, for example, interacts directly or indirectly with LSAS. Yeah? So there is a technique, create remote thread, and so on. And basically, when LSAS is touched, yeah, that is the moment where antivirus that is smart should react, because there's nothing wrong with this file. It's just a non-executable until it starts working. Yeah? But in general, let's have a look if the executable itself is actually recognized. So this particular file, let's see what's the name of it, 0, 1, 3, and so on. Let's just do choose file. And I'm going to go on my desktop, so let me do it on my side very quickly, to the Ignite folder, and I'm going to run the 013 file. And let me just push it here. Confirm upload, that's this one. We're uploading it, it's a hot Mimikatz, nobody has seen it before. And then basically we will see what's the detection ratio amongst different types of antivirus in this world, yeah? And this is, by the way, what we do every single time before the pen test with all of our tools. We actually run them through different mechanisms so that when I go somewhere, I don't have to worry about such an old school thing, which is an antivirus, yeah? And until we've got the machine learning implemented, it's gonna take some time. So here we go. No product placement, nothing here. I'm kind of laughing always because Sophos renamed our company name. We're not Sequire, we are secure, but okay, that's not us, basically. Yeah. I don't know who that is. So when we move forward, we can see that 10 out of 71 said is bad. Yeah. So now here's the difference. When you've got an antivirus solution, or like even something bigger, that relies on the intelligent threat detection, when the Mimikatz is working, that will be discovered. But when you've got a regular antivirus, this is a good example over here, that tool will just simply work. Yeah? So this is basically the difference that we are dealing with right now. This is this modern malware kind of thing. So it's not really like being modern over here, it's about the modern detection, yeah, that we should care about. Okay, so this is a little bit of a demonstration. Now, whenever we are thinking, of course, about different ways of executing the code, we could say, okay, then I don't want to know. I'm just going to block all of the executables that I don't know and I don't care. Yeah? Is this good? Well, not really, because we've got also DLLs. We've got also scripts. We've got PowerShell, fantastic hacking tool, maybe we shouldn't even say that it's a hacking tool, but it is a kind of hacking tool. Lots of things that are currently bad are actually in PowerShell. So the question is, how are we able to run code through different types of operating system files? Let's have a look, if you don't mind. First of all, we're going to run, let's do the PowerShell first, and then we're going to do the debugger second. I've prepared a little bit of a demonstration over here to show you how we are able to attack certain type of a target by using a PowerShell exploitation library. Okay, so this is basically working like this. We've got over here an attacker's machine, yeah? And within this attacker's machine, we're going to be connecting. Now, what I have over here in my hand, that's something that is called DigiSpark, yeah? And again, I mean, this is a very cool thing. I got also Rubber Ducky. Rubber Ducky is a little bit older. Let's use something cooler. DigiSpark is a little bit of a more challenging device. Rubber Ducky is for kids. This one is a bit challenging because it provides you the full USB functionality. You can technically play. If you are one of these manual guys doing this, then this is a fantastic opportunity to have fun. And within the DigiSpark, and on the DigiSpark, you are able to build whatever USB functionality that you want. So after the session, I'm happy to show you how it looks like. Yes, or you can look it up. It's simple. So what I have over here, it's the code that within the PowerShell allows to execute something on the victim's computer, on the target's computer, and then connect back to the hacker. Now, what we're going to be doing over here, and I have over here a website that a hacker has. So this is the hacker server. We're going to be uploading over here on that server different results of our operation. Yeah, I'm going to refresh it so that you can see it's clean. So let me take this off for the moment because we're going to be connecting to the attacker. Okay, let me plug it in. It has like a small diode, so it's like red, it's working. It works with a 7.5 second of a delay. This is optimal. And then basically in a moment we're going to see the connection happening. Yes, it's going to take this time. And what is executing underneath, it's a PowerShell. Yes, so we've got a PowerShell exploit library. This is something that I will show you in a moment, how antivirus can actually detect it. So we're going to look at this from two sides, when it's not working and when it's working. So over here, what you can see, we are already here. Who am I? You can see that I have attacked myself. That's exciting. Makes my day. But anyway, we can see over here that we've got, let me just take this off. We've got over here the new object system, that web client download string, and we're downloading the CQ post exploit library. This is our custom library. We're happy to share it, of course, that allows us to do the different types of exploitation activities. Yeah? So let's paste it over here. Yep. Okay, we got this. And now this particular library can do different types of things. Yes, one of the things we've got, so this is very straightforward. So let's just have a couple of short examples and then we will move forward. What we are able to do. Yeah, so it acts as a user. So we are able to make a screenshot, for example. Here we go. I'm going to run right now a couple of things and then I will show you the result. Webcam snapshot. It's going to be awkward, but let's do that. Here we go. Okay, cool. And then let's see what we got, yeah? So, interesting perspective, by the way, because over here, we've got these two pictures. So this is basically screenshots. So this is what I have right now. And this is, yeah, let's do that. That's basically, that's how I look every day. Like, this is my normal face. This is when I see an antivirus that can be stopped. Let's move forward. So why did it could execute? Because there was a PowerShell running, yeah? Are we able to detect it? Yes, I will show you this detection in a second. But what is quite interesting over here is that we tend to, by the way, small comment, cover our cameras, yeah? And we've got all these gadgets. Do we actually cover our microphones? Yeah, right, like nobody kind of invented that gadget. I don't know what that will be, like chewing gum or something. Yeah, but it's better to see us or to hear us, yeah? So just a little bit of a comment, yeah, because we really care about this, but we don't kind of care about that. Okay, good. So what else can we do? Just to show you one more short example, yeah. So I have over here start keyboard replacement, yeah. So we are able to replace basically the keyboard as well, and everything can happen as a user, and that's beautiful. So we are able to paste that. Before I launch this, let me run one thing so that we are able to see what we are actually copying over here, okay? So this is a typical situation in malware where we are able to listen to whatever someone is typing, so or putting in a clipboard, account number, so this is an invoice. When we copy this, let me do that, and I'm going to put it in a regular notepad so that you can see that it works. So here, it's the same thing, right? But we're going to minimize that, and then this one we're going to execute. And let's get into this PDF. We have a bunch of seconds to do it. And we're going to copy it again. And then we're going to go to Notepad again, over here. And then I'm pasting it, yes? So this is basically replacing simply a clipboard. Why this is working? Because a user even can do it. So we don't need to be privileged in order to perform this kind of activities. Now, everything, of course, ran over there was within the PowerShell. Now, one more thing to show you, and then detection, of course, is this. Have a look. I've got over here an Excel spreadsheet. Yes, this is also a typical way how malware actually gets somewhere. Yeah? So this is an Excel spreadsheet. Now, within this Excel spreadsheet, we've got something that could be a macro, right? So there's like calculate salary button. Yeah. Now, interesting perspective on that is that, let me get to the attacker's machine. So we're going to go exit, and then let's rerun the listener, because we're going to be connecting back again so that you can see it works. So this one is waiting for connection. So this is a typical way of doing it. Now, what wouldn't you do? We won't click on the calculate salary button, that's for sure. Yeah. But the funny part is that, I don't know if you guys have that, I kind of have that. Like when I see an Excel spreadsheet, I want to click somewhere in the empty cell just to know where I am, kind of thing. I feel it's a comfort thing, I feel better about that, yeah? The problem is that this particular macro has been designed in the following way. This is a picture, yeah? So people that are like, haha, I'm going to be smart over here, they're not, yeah? That's the point. And I like it because it's very vicious, yeah? So basically, wherever you click, I click here, it just says wrong number. This is just like because we display it, yeah? It doesn't matter what it says, actually, it doesn't really matter. Now, when we get back into our attacker's machine, let's have a look at this one. Yep, it is this one. We can see that here we are connected back again, yeah? And again, underneath, in that particular macro, we had a PowerShell that executed. You know what's positive nowadays? That quite recently, Microsoft introduced in Windows Defender ATP the mechanism that informs you and blocks at the same time when Office runs PowerShell. It doesn't matter what. And that's cool. Yeah, because like, why should that happen? Yeah, intelligent threat detection. Now, when we look at that possibility, like what was actually discovered out there, yeah, let's have a look. I have prepared over here a dump of activities that are related with what is actually happening. Yes, so we can see a script with suspicious content was observed, malicious power system that was invoked on the machine, and so on. Yes, so we can have a look. So this one, machines list, let's see. We've got over here a certain type of a machine. Let's just have a look at this particular machine over here. And we can see suspicious PowerShell command line, for example, yeah? And we can see, what was it, yeah? So we got a payroll, power cut, attacking, and so on. And this is basically this particular command that was running. And we've got over here Excel, PowerShell, who am I, and so on, CSC, C# compiler. So in general, not only there is actually a malicious PowerShell running, but we are able also to detect the situation where Office application runs suspicious commands, when there is in general a fact that some of the commands were started by Office. Yeah? So this is what we understand by, in general, modern detection. Yeah? Normally, when we don't have that kind of solutions, these macros go through, and that's where the problems happen. Yeah? So that's just my, as I mentioned, independent comment. Yeah? Okay, so let's have a look further. So whenever we are thinking, of course, about different types of other techniques that are used by malware, could it be, for example, that we could, through the debugger, inject something into like some other file? Yeah, so could we run, for example, some malicious code through debugging tools, yeah, and so on. So one tool, one bad code through another one. So while debugging a certain type of a process, during the debugging process, we're going to inject something, yes? Of course we could do it. This is not that much exciting, but it's also one of the ways of how we're able to actually do that, yeah? So let's have a look how we're able to proceed with this. Not this one, sorry, here we go. Let me just get there. Yeah, that's this one here. So we've got over here a certain debugger. Let me just get to the path very quickly. Okay, here we go. Yes, 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 this is this one. Yes, so there is a cdb.exe. One of the ways how we are able to bypass it, just to tell you. So whenever we've got a cdb.exe, through CDB, we are able to actually define that we should, for example, run a certain type of malicious code within the debugging process, yes? And I would like to show you how to do it. So within the cdb.exe, we just specify -cf, and then I have over here a certain type of a WDS file, which contains a debugging commands that allow us to inject a complete code within the debugging process. So in this particular case, we will specify that we would like to run notepad.exe, for example. Yes, and over here, what it will start, and that's basically what I have inside the code, a full character map. Yes, so it's just an example. Yes, so that we are able to, during the debugging of Notepad, we're able to start some other software. Yeah, so this is basically the case. But let's get into something more exciting, if you don't mind, and that's going to be our live scenario for today. So I've got over here a machine, and this is pretty cool. So this is this machine, and within this machine, here we go, I've got on it a malware running, yeah? And again, I totally love these kind of challenges, yeah? So you are like put on the deep water, and then we're supposed to find out something that we don't know what we are looking for, yeah? So what we're gonna start with, maybe with some kind of processes, yeah? So let's go into the process hacker. I'm gonna run it with administrative privileges, yeah? And over here, what I will need to check, it's a verified signer. So I'm sorting this, and I can see that ILSPY is not digitally signed. Oh, that's great. But anything else, besides Process Hacker, it's Microsoft Windows and Microsoft Windows Publisher. So where is this malware? Yeah, so it could be injected in one of these files over here. And one of the things that should definitely be checked over here, it's what kind of DLLs I have running that are running in these executables. You can use, for example, list DLLs for that and verify digital signatures and so on. There's lots of DLLs, unfortunately, they are still not digitally signed, and that's a bit of a problem, yeah? But one of the things that we can see, of course, we could guess that maybe it's around DLL or something. Yeah, maybe. But one of the things that I would like to show you is how to list, because this particular malware is, for example, communicating over the network, how to list this type of communication. And basically, in a simple case, we've been doing this on the previous session. Today, right now, I would like to show you how to do it in a little bit more advanced way, where we are getting the whole context of what's happening, and that's pretty cool. So what we're going to do in order to get this? First of all, we're going to run xperf. And xperf, being an amazing tool for troubleshooting, for information gathering, and so on, and also, in my opinion, one of the most difficult tools, would definitely help us to connect the dots. So let's see what we are able actually to do with xperf. And with xperf, first of all, when we run xperf itself, we're going to run over here next xperf providers, like this. This shows us different types of providers, so information deliverers, so guys we can ask to give us more information. It's a lot in general. Sometimes it's quite confusing. That's why xperf is so cool, because it provides us different types of groups, how we're able to gather data. So you can see these are these groups, but I don't know what to search for. Well, then it's okay, because we're going to search for processes and threads, maybe loader, maybe profile. Profile, it's a CPU time. And then maybe we're going to look at the network trace. So let's have a look how we're able to perform that type of a search. And that's actually quite easy. So within xperf, we're going to run the following command. Let's do it. Xperf, let me put it up maybe so that everybody can see. Yeah. So we're going to xperf, here we go. And then we're going to do on, and we're going to do proc_thread, like this, plus loader. So we're going to see, are there different types of DLLs, sys files, image files in general loaded. And then we're going to do network trace, like this. And then we can specify over here all this cool stuff like, for example, buffer size, minimal buffer, maximum buffer, file mode, should it be circular, and so on, maximum file size, and so on. Let's keep it, yeah? We can just keep it simple. Yeah, okay, this is funny. By the way, xperf error, anti-kernel logger cannot create a file when that file already exists. And be smart now, I don't know what they are talking about. But what we're supposed to do, we're supposed to switch off the process hacker and then it works. I'm kidding, of course, a little bit, yeah. That is actually because we're connected to the same logger. Yeah, that's why this information, but the message is very irrelevant, yeah. Okay, so we've got xperf. Now, we're gathering information about what's going on and so on. And then we can stop it, yes? So we're going to do xperf in this way. And we're going to just simply do stop -d and dump. And then we are doing network ETL, like this. So we are dumping the whole communication into a certain type of a file. Now, in order to be able to see what's inside this file, we need to run xperf. And then we're going to do -import network ETL -input output. We're going to do network .txt -action dumper. This is the name of the actions in xperf. Xperf has several ways to work on data. That's why it's so cool. Yeah? And over here, we got that pretty short. We are able to find, let's just use over here maybe find string. In this case, not case sensitive, TCP send, so the whole communication in the file. So our file, it's network txt, enter. And then we're able to see and confirm that this is indeed run DLL communicating over the network, yes? So there are many different angles how we're able to actually see what's going on. Now, interesting. When we find this, we're like, oh, okay, let me have a look at this run DLL. So let's get into the process explorer, or process hacker. Oh, I mean, it doesn't really matter. Okay, well, it matters, of course, because one is by the different outer. But anyway, we're able to see run DLL, properties. Let's see. So we can go to general over here, and then we see that this is like, that we've got some DLL. I've named it this way so that we can see it's bad, but it's some DLL. Now, when we are facing this type of situation, guys, how do we analyze this? What do we do with this DLL? Yeah? So it's going to, in general, it's going to be a native code, or it's going to be a managed code. So C, C++, or C#. Yeah? So it really depends who we are friends with. We can send it to different types of developers for analysis. But there's also something we can do by ourselves. And this is something that I want to show you. So when we can see this DLL, we can copy that. And I have this in the analysis folder copied. And then we've got two tools that are really nice that I would recommend to have a quick look at. One is called PEBrowse Pro, and it's free. So what you do, you take this DLL and you drop it there. And another one is EOSpy that we already know, and you do the same thing. Yeah? This is how quickly you are able to see what type of code that is. This one says, this file does not contain a managed assembly, yeah? Which means it's not a managed code. Over here, we're still waiting. Yeah? This one is disassembling it, and we are able to see what type of code that is. Yeah? Now, as we mentioned at the very beginning of the presentation, we can put one file into another. Yeah, so there's a wrapping. Sometimes we need to solve some puzzle to get the file out, but it could be also concatenated. So we don't know pretty much what technique is used, so we can find out. And we can see over here that if we get into exports, we can have an export called run client. Let me minimize this one. And here, if you totally love assembler, yeah, you can, is there someone like this in the room? Wow, okay, pure love for sure. Okay, good. So we are able to see, and we are not getting into assembler, don't worry, that there is different types of files that we are using. So for example, there is one important file, mscoredl. This indicates .NET. So hey, we just learned it's not .NET, but here we are able to see that this is .NET. Okay, let's have a look into another tool. And this one, it's called Resource Hacker. This is a tool that I've been using also a long time ago to do different things with games when I was younger in the local area network with my peers. Very good to change different executables for different reasons. But here, This is a very useful tool, and I completely love it. So here, it shows us the structure of the file. And in this particular case, we've got actually file in a file. Resource Hacker allows you to see when the file is over, and it also gives you the rest of the file. And that's why it's called binary. Now, this binary has a very nice beginning. It's called MZ. And that is an executable. Yeah, MZ, by the way, stands for the guy that invented that. He's from Poland. His name is Marek Żbikowski. So a little bit of a Polish root somewhere. He's probably more famous than Madonna, more records, yeah? Anyway. Anyway. I have a bad sense of humor. Okay, anyway, so let's take that. Save all resources, yeah? And then what we're going to do, we're going to save that into C analysis. Analysis. Like this? No? Okay, let's just see that in the C drive. Oh, come on, can't save here, why not? Okay, yeah, okay, let's just keep it this way. Name, oh my goodness, why am I not thinking? Here we go, data, let's do it. Great, so we've got this, fantastic. We've got here data 1 bin, and this is something that we can put in here in the ILSpy, we can try, yeah? And here the full adventure starts, yes? Because this is the moment where we are able to have a look into some part, malware client lib, here we go, some part of the code, and try to analyze of what's happening. Yeah? So, and this is endless, yes? Because this code, of course, it could be obfuscated. It is actually obfuscated. We've got over here a resource. This is a typical way of doing this by malware. Remember, I showed you Coinvault. When we look at the original Coinvault library, same thing, resources. Yeah? And there's an encrypted resource, and here is an encrypted resource too. Yeah? So in order to get it, you need to solve the riddle inside the code to get it, and then 40 times the same thing. Yeah? So this is basically what makes it complex, but at the end, what I'm trying to say is that these techniques are pretty much the same. Okay, guys. So when we look at different types of malware that we are dealing with right now, we play with PowerShell. We play with loading a DLL into the file. This is a typical load library function, yes? Like vast majority of these things that we were looking at, they could be prevented not only by the antivirus solution, but by also exploitation prevention. Yes? When we are loading the library into the file, when we are, for example, performing things like process migration, so putting the directly code into the memory of the other process, these are the typical techniques that are used nowadays by that type of solutions. And the reason why they're used is because the amount of techniques that we have is limited. Yeah, so once we are using the intelligent threat detection nowadays and exploitation prevention and supply it with the code execution prevention, this is currently a really nice working solution to prevent all of these sad situations that are happening in this IT world, which of course I wish you all the best that you all get this. And none of these situations like we had in a vacation, as I mentioned at the beginning of the presentation, will happen to each of you. Hopefully it was an insightful look into what malware is right now in the world. If you're going to have some questions, I'm here. And if you don't, then I would like to invite you, of course, to the next presentation that I'm going to be having in Hyatt. Don't forget, guys, to get the quiz. Yes, to fill up the quiz if you are in a mood for relaxation. And to get slides and tools, this is basically the place where you are able to download all the stuff that we are doing. There's a special post for Microsoft Ignite. My last presentation is going to be packed with tools, so if you are ready for some hardcore at the end of the day, definitely please join me. Thank you so much for coming.